from Global IFS here. In the run-up to the 2021 Mass Timber Conference, I'm joined again by our panelists of experts, Chris Irvin, our Mass Timber Specialist, and Matt Bumbla, our other UFAD expert on the East Coast here, actually. And we're going to have a conversation today, so I'll let Chris take it from here.
Well, welcome to the 2021 International Mass Timber Conference, virtual as it is, but we're making the best of it. And I'm sitting here in Denver, and we're talking with my counterpart, Matt Bumbla, who's based out of Atlanta, and gonna get a understanding about how HVAC systems affect the health and safety of the indoor air environment in today's office environments, and understand if it can play a role in making our workspaces healthier and better places to go to work. So, Matt, why don't you kick us off?
Absolutely. Thank you, Chris and Braxton, for having me on the panel. To Chris's point, we'll talk about, air distribution systems and how they play a role in terms of providing healthier environment for occupied spaces. Now, before we get into, what are some of the methods, that could, lead us into that direction of providing healthier environment and minimizing exposure for our occupants, it's important to understand, what type of air distributions there are out there that exist, so you could compare and contrast, different systems. Now, anyone who's worked in the HVAC world will obviously understand that there's many different ways of doing your HVAC systems. You could, probably say there's more than 50, maybe close to 100. But when it comes to air distribution, really there's really just two broad categories. One is your overhead mixing, which is, what's been around for last 70, 80 years, since Second World War, maybe even before that. And the other is stratification. What's the difference between the two? Essentially overhead mixing is, what you see on the left side of your screen. This is where, if you look up, most likely you'll see a diffuser up in the ceiling. And the idea is that diffuser introduces the air at 55 degrees and high velocity. And the idea is to mix the air within the space. The goal with these systems is to provide a homogeneous environment. What that means is, essentially you have, 75 degrees your set point. Again, an ideally designed overhead mixer system will have 75 degrees throughout the space, from the floor all the way up to the ceiling. At the same time, again, because you're providing mixing, essentially you have a homogeneous, contaminant level within the space as well. On the other hand, there's stratified air systems. And as the name may suggest, with stratification, you're not mixing and you're not providing a homogeneous environment. What happens is, as human beings, we're a warm-blooded species and we dissipate heat. We add heat to the space, and there's a lot of equipment that we add into our spaces that also adds heat to the space. It could be our computers, monitors, printers, and a lot of other things, including lighting. What happens is anything that adds heat or transmits heat ends up heating the air over their surface, and hot air wants to rise. This is going back to high school physics, right? Anything that's hot especially air, is lighter than colder air. It wants to rise. So you naturally have a heat plume rising over our surfaces, or any equipment that's adding heat to the space. And then you basically, with a stratified air system, you're trying to create a natural way of conditioning the space and the occupants. How that works is, instead of doing an overhead system like we talked about 2 minutes ago, you basically have floor level diffusers that are introducing the air into the space right next to the occupant at low level and at low velocity. At the same time, you're introducing them at a little warmer temperatures as well, 62 to 65 degrees, because that's what makes it a more comfortable system for the occupants. So, essentially what happens is, again, very contrasting systems. With one system, you're trying to create a homogeneous mixed environment. With the other system, you're relying on the natural phenomena of heat plumes rising over a surface and using that to condition the occupants. And you're stratifying not just the temperature within the space, with the coldest air at the floor level, warmest air up at the ceiling level. You're also stratifying the contaminants with higher concentration of contaminants at the ceiling level, versus at the floor or in the occupied space. So, I already talked a little bit about heat sources and heat plumes. This slide kind of does, provide a little more information on it. And again, as occupants, human beings, we dissipate heat. Heat plume is rising over our body. That's what draws this cold conditioned air towards us, providing us, a higher dose of fresher air, and that's how you condition occupants in a stratified environment. To give you guys a little bit of a visual of how this works, I'll play this video in a sec, but essentially what you're looking at here is you've got 3 heat sources shown in the space itself. These dummies, they represent a typical human being, 250 BTUs per occupant. What you'll notice is when I play the video, air will start coming out of this overhead diffuser, showing how a mixed air system works. Let's play the video. So a couple of things to note here. One is, notice the velocity at which the air is coming out of these diffusers, and notice how the air as it comes out hugs the ceiling, hits the wall, and tries to create a mixed air environment within the space itself. That's, essentially a well-designed mixed air system. And one thing you would notice is because you're mixing, if this was an occupant, that say had a flu or was infected, was to sneeze or introduce contaminants into the space, those contaminants, chances are, will be picked up by the air and, and will get mixed up in the air, and other occupants within the space, may have a larger exposure to those contaminants. On the contrary, with a stratified air system, this is again is the same exact room, and you're looking at the same heat sources within the space itself. What we're now going to change is, instead of introducing the air using overhead mixed air system, we're going to introduce the air at the low level by using a stratified air system. What you see on the wall here is a displacement diffuser. It's going to introduce the air again at the low level, and it's fed through the underfloor air plenum, which could be done through floor diffusers as well. But this is what was represented for this video. And again, notice how the air comes out, the velocity of the air, and how it interacts with the heat sources within the space. So you could see the air starting to come out of the diffuser. Hopefully you guys are seeing the difference in the velocity from an overhead system versus a displacement system. And again, very contrary to the other system, as the air comes out, hits the heat source, the heat plume that's rising over this heat source is what's drawing the air and conditioning that heat source, both for temperature and for fresh air as well. And what I also like to point out with this video is, this is science. This is how it works both biologically and physically as well. Biologically, we're designed to add heat to the space, and hot air always rises. It never fails to repeat itself. As long as you have heat sources within the space itself, the cold air that you're bringing in through your floor diffuser will find the heat source, because again, it's the heat source that's driving the air movement within the space itself. Now, what happens, with this is, in terms of the standards, ASHRAE 62.1, that's our ventilation or our outside air standard that we're used to using here in North America, and they recognize this. So what they say is, if you're using an underfloor air system, if it's a space that's 18 feet or smaller in your space height, you could claim ventilation effectiveness of 1.2. What that means is, based on your ventilation rate procedure, whatever airflow you're required to bring in from the outside, you could divide that number with your ventilation effectiveness. So with an overhead system, at best, you could achieve 1 as your ventilation effectiveness. With underfloor air system, when designed right, at minimum, you'll have ventilation effectiveness of 1.2. So you could reduce your ventilation air requirement by at least 18%. In a lot of the cases where you have ceiling heights that are greater than 18, it allows you 1.5 ventilation effectiveness, which provides you even further credit. There's a lot of the projects that actually, where clients want to provide more fresh air for their occupants. In those cases, you don't have to reduce the ventilation air. You could use this credit to enhance the environment for your occupants and claim higher lead points as well, because you're bringing more fresh air compared to what the standard may ask you to do. Now, another thing that's important to understand is, one thing that we notice a lot, on projects is, the general perception in the market is, if you're using an underfloor air system, you could just claim 1.2 ventilation effectiveness, no problem. There is one nuance to it that's important to understand. As an industry, and especially as mechanical engineers, what the standard says is if you have a floor supply diffuser, an underfloor air system, you can claim 1.2 ventilation effectiveness when your diffuser throws no more than 4.5 feet. That's important to understand. The reason is if you have a floor diffuser that throws higher than 4.5 feet, your ventilation effectiveness is only 1. And again, the reason for that is if you throw way too high, what you're now doing is you're throwing high velocity air up closer to the ceiling. That's where all the contaminants are that have risen up from the space. You're disturbing those and you could end up entraining them back into the space itself. Essentially, you end up creating a mixture environment using an underfloor air system. So it's very important to understand when you're designing these systems that you have designed them around the right diffusers that do never throw higher than 4.5 feet. That's how you ensure you've got a system that's doing what it's designed to do. So talking about diffusers, hopefully we understand that it's important to understand how these diffusers work and they do the right thing. There's different types of diffusers out there. You can find grills that are not really designed to optimize the performance of the system. They throw way too high, and those are the ones you want to stay away from. At the same time, there's variations in diffusers that provide the right performance, and you want to be aware of what's out there in terms of what's available in the market, so you could design your project the right way. Now, there's what you see on the screen is there's two different categories. One is your swirl diffuser. This is what's been around for 20, 25 years. These are your round floor diffusers that usually throw 3.5 to 4 feet, still stay below 4.5 feet. But what they do is they provide partial mixing, so essentially some mixing in the occupied space and stratification above that. And then your displacement diffusers, these are the ones that pool the air completely on the floor and provide 100% stratification within the space. Let me play this video. I'm going to cycle these videos at the same time so you guys can see the difference between the two diffusers. What's on the left is the swirl diffuser. You can see, it's throwing below 4.5 feet, and what's on the right is your displacement diffuser, which is pooling the air on the floor 100%. What we would notice is even though the swirl diffuser started bringing the air out first, it's the displacement diffuser that was able to get to the occupant quicker. There is, really nothing else that's out there which will bring the fresh air to an occupant as quickly as a displacement diffuser. And a simple reason is because we're relying on the heat source to draw the air towards it, right? So when we're talking about cleaner air, getting the fresher, cleaner air that's filtered and it's going to minimize our exposure to the contaminants around us. Again, it's the displacement diffuser that's going to give you your best chance of protecting your occupants. Now, sometimes the question comes is, what happens with ventilation effectiveness from one system to the other? This what you see on your screen comes from the study that was used by ASHRAE 62.1 to come up with the ventilation effectiveness, for these systems. And you could see what happened was they built a space where overhead mixing and underfloor air displacement was used. There were sensors all around the space. It's the average number that the standard went with for ventilation effectiveness, which made sense, being a standard. But the bigger point is where the heat sources were, the ventilation effectiveness was almost as much as double of what it would be with a traditional overhead system. And the reason again was because it's the heat source that's drawing all that fresh air towards it, right? So where the occupants are, chances are you'll get as much as twice the cleaner air compared to any other system, compared to anywhere else within the space itself. So from your occupants' perspective and building owners' perspective, that's really what you're bringing to your employees, to your people, giving them the best chance of getting the cleaner and a most productive environment. And one point I wanted to make, before we, wrap up this conversation here and get into the Q&A session, is, with the displacement diffuser, sometimes the question comes about comfort. ASHRAE 55 is a standard for comfort. all the diffusers that essentially we have at Global IFS, all those designs have been tested for the draft rate test. What's a draft rate test? A draft rate test has our diffuser designs, measure velocity, temperature, and turbulent intensity going vertically up and horizontally away from the diffusers. What we found was, because how slow the air comes out of the displacement diffuser, it essentially means you could literally be sitting right on the diffuser with the chair being directly above the diffuser, and majority of your occupants, more than 80% occupants, would still be comfortable and satisfied. With swirl diffusers, you typically want to be at least 2 to 3 feet away from those diffusers. Places where you want to use swirl diffusers is where you have high airflow requirements and your diffusers are further away from the occupants, as you guys can imagine, right? Your hallways, or your private office area where the diffuser is not close to the occupant, that's where you could use, or you want to use, swirl diffuser. In tight cubicle spaces, that's where you want to use displacement diffusers, because your occupants could be really close to these diffusers. Now, having made the point, I think there's really not never been a better time to talk about cleaner air, right? Especially with the pandemic that we're in and what we're hoping to achieve over the next few months for ourselves, as we all figure out how to reopen our spaces. Stratification is something I feel that all of us have to keep in mind and evaluate for all our spaces and our projects. If there was ever a time to pay attention to your air distribution, it's today, because again, prioritizing our space air distribution can really, take things to the next level in terms of what we could bring to our occupants. With that, I'll give it back to you, Chris.
Well, thanks, Matt. That was excellent.
Hey, Chris, you're having no feedback. I can just let you know.
Not sure why that is.
Oh, it's okay. Let's just go with it.
It seems to me that the way displacement ventilation works, that essentially you as the heat source create a bubble of the cleanest, freshest air around your person, and it just constantly refills itself as the heat plume carries that air up. That seems to be the most comfortable and healthy way you could possibly cool a space. Is that a good impression?
That is, Chris. I think that's a very good analogy. It's essentially there's a lot of research that has gone into these systems, and these systems are not that they just just recently are getting introduced. They've been around for at least 20 years, and people they'll provide you your feedback, where the ones that have been in a mixed air environment versus a stratified air environment with displacement, they'll tell you how different they feel, how better they feel their displacement system, for all those reasons that you mentioned. It's essentially a virtual bubble that you create around yourself of comfort. It's not that it's a foolproof system. If someone sneezes, you could disturb the velocities, right? So it's not perfect or ideal, but it's the best thing that's out there that we could use to enhance healthier environment for our occupants.
Yeah, and Matt, maybe one question further to that point. That idea of kind of future readiness that you kind of brought up, and being able to build confidence in the performance of our buildings in the future. I mean, that's one of the main reasons why mass timber buildings have become such a popular option over the last decade or so, is that on top of, we talked a little bit about this with Jack, on top of, this whole story of carbon storage and being more, using less greenhouse gas, having less greenhouse gas emissions in the construction process. One of the other reasons, which I think relates to this presentation, has to do with buildings where people actually are comfortable and they're happy. They don't necessarily, suck your soul in their future proof, not only in that, or future ready, not only in that people want them to be around, but they're future ready in that they will encourage performance so that people want them to continue being built. How do you see that story playing out? Having worked in UFAD for a number of years now and knowing a little bit about mass timber, you've been really involved in this whole future building type concept. How do you see it playing out in the future?
Yeah, so I mean, I think mass timber is, one of the greatest initiatives that I have seen, us taken up as an industry, that I've been part of for last 15 to 20 years, for all the right reasons. Why are we taking up mass timber? We're taking it up because we want to provide that biophilic environment for our occupants so they feel good. It feels as close to being, working outside when the weather's nice, as you would working inside, right? Plus, carbon neutrality, and providing, buildings that are, again, contributing towards providing carbon-free environment. And that's where displacement is as well. It's such a natural way of conditioning occupants. If we're doing mass timber buildings for all those right reasons, that fits right in. It takes the building to that next level of, okay, we're not just going to do the right thing with the structure of the building and what you see around you, but also how the air is introduced into your building fits right into that same narrative of why we do mass timber buildings.
Mm. Yeah, no, I think that's a great point. Chris, do you have anything you want to add to that? I just think it's such an interesting topic.
No, I think, Matt hit all the high points. One other, I guess, concept that we might discuss briefly at least is underfloor air systems obviously have a natural level of indoor air quality that is much higher than overhead systems. We have much lower levels of contaminants in the breathing zone, which is a huge plus. But now, can we make it even better? There are air purification strategies out there, and how do they dovetail together?
Yeah, that's a good question, Chris. I think so if you think about some of the active technologies that help you scrub the air, not just in your duct system, not just in your air handling system, but actually in the space itself. For example, bipolar ionization, where you're able to introduce ions in the space and actually clean and purify the occupied space. I think that's where underfloor air systems can really help, because what happens is with those ions, they have shelf life, right? They don't last forever, right? The more they have to go through, the more they get the quicker they get consumed, right? And they're not able to get to the occupant that they need to get to, right? So if you have systems where they have to go through all the ducting, right? Tens of feet of ducting before they get to the occupant, plus they get introduced at the ceiling level and travel another 10, 15 feet before they get to the occupant. They're going to pick up contaminants, right, that they have to deal with before they get into the occupied space, right? With underfloor air systems, you could bring the introduction of those ions a lot closer to the occupant itself. You could generate them right in the plenum where you're introducing the air into the plenum, and they're coming up through the diffuser right where the occupant is, again, instead of having to travel all that distance. So I think anecdotally, yes, with systems like bipolar ionization, you should and you would have that additional benefit of improving the active life of the ions in your building.
Perfect. Well, maybe that's a deeper discussion for another day. Unless you have any final thoughts, we'll leave it there, and wish everybody a great time at the Mass Timber Conference.
Yeah, thank you for joining us today.
Okay. Thanks, Matt. Everybody have a great day.
Thanks, everyone.